you?
Thank you for joining us late. No, I wasn't. We missed some stuff at the beginning. That's okay. Anyone who missed this can go to my Block B video. Okay, so we're jumping right into the middle of this. Instead of doing 13 times 8, what they did was 13 times 10. If you do 13 times 10, that's more than what you wanted. So what do you do to compensate? You take the 13, you multiply it by the 2, and then you take those 2 away. You betcha. 13 times 2 is 26, and now we're going to subtract that. For some people, it's easier to subtract down than it is to add up, because 30 minus 26 is 4, so that's going to give us 104. The result is the same. It sure as heck better be the same, because that's the way math works. But you've got multiple ways to think about it. You can write it out longhand, or either one of these techniques can be done relatively simply in your head with a little bit of practice. I don't particularly care which way you choose to do it. What I am going to do, though, is I'm going to give you a bunch of BEDMAS questions tomorrow, and I'm going to say, you got to demonstrate this without a calculator. So that means if you want to do it longhand, but developing some of these mental tricks, and then, not tricks, techniques, and practicing them is going to do a lot of good for you. Okay, next one. 13 times 11 then is what? Let's do it a couple ways. Yes, sir. 143. How'd you do it? You did 10 times 11? Okay. Oh, yeah, you did 10 times 11 and then 3 times 11 and added those up. So it's going to be 110. That's going to be 33. That's going to give you 143. You center? Sounds great. One way to do it. Did anyone else do it another way? There's the algorithm, right? The algorithm's the one that you've seen before. If I'm going to do it longhand, for those of us who like longhand, what does longhand look like for this?
First you do the 13 times 1, and then you put the 13.
So the 1 times 3 is 3, the 1 times 1 is 1, okay?
And then for the
this is where
one,
things get weird.
You're going to put it 1 forward. So
Why?
3 will be underneath the 1. Well, I'm not actually sure why. My dad just taught me this way, so I'm just like, okay, I'm just going to do it and not ask questions. Because math is my strong suit.
Math doesn't have to be your strong suit, but math can become your strong suit if you're willing to ask those why questions, and then they might actually click. The why is exactly what you did before. You did 10 times 11 and 3 times 11. So here, what we've just done is the 3 times... No, we're doing it the other way. We're doing 13 times 10 and 13 times 1. We're actually breaking it up differently. 13 times 10 and 13 times 1 is what we're doing here. 13 times 1 is 13. 13 times 10 is 130. The reason you move things over, or some of us, one of the persons in my other class, Yuvraj, pay attention here, man. Yuvraj. And Sahib, if you're on your phone, put it away. The one student said, oh, just put an X here. We don't want to put an X there. So you just said, oh, just move it over. We don't want to just move it over. When you actually go, if you're going to do it longhand, you actually want to toss the 0 in here, because that's what you're doing. You're multiplying the 1 by the 13, and now we're going to go ahead and multiply the 10 by the 13. And when you multiply 10 and 13, the first thing that happens is you toss a 0 down there. And now we're going to multiply 1 by 3 and 1 by 1. Add those two results together, just like we would do down here. And you get, for the third time... Okay, Annabella and Geronimo, it is hard to concentrate over top of your guys' chatting. Third time, you get 143. Again, whether you choose to do it longhand or you've got a technique in your head, that is what I want you to practice. Geronimo, stop talking. Unless it's related. It doesn't sound like it is.
169.
It is 169. There's another technique for these. What's special about that question? It's a perfect square, which we'll look at more when we talk about exponents. For those of you who are hanging out on the multiplication tables, The perfect squares are the diagonal. The number times itself. 169 is right. Where is you? Right there. 13 times 13. Some of you just memorize the perfect squares, and that's great too. But there's all sorts of ways to do these things in your head. Okay. Let's go ahead and justify why multiplying two negatives gives you something positive. Stop me at any point if you got any questions. Okay, you were told at some point in the past and you were asked to memorize the fact that multiplying two negative numbers gives you a positive number. And then a whole bunch of you yesterday, or no, not yesterday, it was the day before, tried to abuse this rule when you were talking about addition. Don't just memorize rules and then forget how to apply them. If you actually think about what the operations mean, like instead of just multiplying rules to get math done, just make math a part of who you are, which some of you are like, nah, it's never going to happen. Addition with negatives is just moving back down the number line. What is multiplying with negatives? If one of them is positive and the other one's negative, now you're just skip jumping down the number line because multiplication is just repeated addition. But why is multiplying two negative numbers positive? It's hard to picture this, I think, the way we picture it with grouping, because it doesn't make sense to have a negative number of groups of negative things. So what I'm going to do is, instead of thinking about it that way, what I'm going to do is I'm going to treat the positives and negatives as if they were directions. So I've got two numbers here. I've got positive 3 times positive 1. I'm going to treat one of those numbers, the sign on one of those numbers, as the direction that this little guy here, Pac-Man, the direction that he's facing. And I'm going to treat the sign on the other number as the direction he moves. So you got two directions here. One, which way are you facing? The other one, which way are you moving? So if I have positive 3 times positive 1, I am facing positively, and I'm going to move in the positive direction. The positive direction is always to the right, because that's the way number lines are drawn. So if I move 3 times in the positive direction, 1, 2, 3, there we are. 3 times 1 is 3. It's exactly what we would expect it to be, I hope. Next one. This one, Pac-Man is now facing negative, which is left. If Pac-Man is facing a negative direction and now moves forward, which way is he going to move down the number line? It's to the left. So he's going to get more negative. If we treat this as directions, it makes sense. He's facing left, moving forward. 1, 2, 3. Here, Pac-Man is down at negative 3. Likewise, maybe Pac-Man is facing forward, but now he's facing positively, but he's going to move backwards. Just like the previous one. The previous one was looking left, moving forwards. Now he's looking right, moving backwards. If you look to the right and move backwards, which way is he going to go? Left. Boom, boom, boom. Still ends up at negative 3, which we would expect. If one of them is negative, your result needs to be negative. This last case is the one that doesn't work for grouping, so we're going to treat it like directions here. If I have a negative 3, that means Pac-Man is facing negative, and the negative 1 means now he's going to move backwards. If Pac-Man here is facing left and is now going to move backwards, which way is Pac-Man going to actually end up going? To the right. Facing negative, moving backwards is going to go 1, 2, 3. The result is positive motion. So this is a justification for why multiplying negatives gives you a positive. Adding negatives makes them more negative. Multiplying negatives makes them more positive. Okay, flip the page. You can't talk about the multiplication without talking about division, because division is just what kind of multiplication? How are multiplication and division related?
Groups?
No. Well, yes. Sort of. Sort of.
Yeah, 'cause
Guntas.
multiplication is addition and division is subtraction.
No. Absolutely. Most definitively. Thank you for giving me a thought. I want you to scrub that thought from your brain so fast. Mila, division is just.
The opposite of multiplication.
That is true. Not what I'm looking for, but a true statement. What is division?
Multiplication, I'm done.
Yes. If you're undoing I don't want to ask that way. Yes, true statement. Not what I'm looking for. Division is just a fancy kind of multiplication. Perhaps you've never thought about it this way. Division is multiplication with fancy numbers. Some of you don't like to call them fancy numbers. What other F word do we use to describe numbers in math? Fractions.
Okay.
Division is just multiplication with fractions. And I will expound more on why that is in a later time. The way you're probably taught about division is that division is taking something big and breaking it down into smaller groups and then saying how big is the group. So if I have 6 and I want to divide that into 3 equal groups, how big is one of those groups going to be? Each one's going to be too big. If I have 6 sheep and I want to break those 6 sheep up into 3 pens, each pen's going to have 2 sheep. This is the foundation for so much math. Organizing the stuff that you have and then ideally selling it to someone else. This is where math was born. So I take my 6 things, 1, 2, 3, 4, 5, 6, 2 of them in there, 2 of them in there, 2 of them in there. And so then the answer to the question is, how big is the group? The group then is going to be too big. Another example, same idea. I have 9 pencils. I want to share them between 3 people. You can picture handing that out, right? How many pencils does each person get? 3. Because the math facts are there. What's the sign for division? The symbol mathematically.
Are we talking about the fraction symbol or like the one with...
No, because you didn't want to talk about fractions before. Good toss. Yeah, like that. A line with 2 dots. But Pevneet, that is the fraction symbol.
I know, but the fraction symbol, my teacher used to use it as the division symbol instead back in grade 8, and she'd be like, this is division, you do it this way.
Well, this is division.
Yeah.
But it's also a fraction. Look at it. It's a horizontal line with a dot in the numerator and a dot in the denominator. The symbol for division is just, hey guys, we're doing fraction math now. You just were often not necessarily taught that. So if I want to divide something, I could write it like this, 9 divided by 3, or I can write it down here like this. I have 15 over 3. This is the same thing as 15 divided by 3, and you treat it the same. How big is the group if I break 15 up into 3 of them, is the question. It's 5 big. Because 15 divided into 3 is 5. You can use, for those of you who don't know, you can use the multiplication table for this too. Here's how you use the multiplication table for division. If I don't give you a calculator and you're stuck, you will always have this tool available to you. Find 15 on the multiplication table. 15 is there, 15 is there. You want to find it on the inside. It's also there, but that's not useful. 15 is on the inside, and I want to divide it by, what am I dividing it by? 3. So you start at the 15, and you want to make sure that the 15 is in a row or column with a 3. Geronimo, wake up! So, it is. It's in the row of 3. So I want to find the other number. Boom. 15 divided by 3 is 5. This is how you use the multiplication table for that. Find the number you're trying to divide in the middle, Make sure it is in the row or column that contains the thing you're trying to divide by. Yes, sir. Yes. There's only one person out right now. I'll show you how that's useful. It's important to discuss 0 here too. What does it mean to have 0 divided by 3? What does that mean? If I'm going to write it as a fraction, that's going to be 0 over 3. And if I'm going to say it, if I'm going to explain it again in words like I did up here, what this means is I'm taking nothing and I'm dividing it into 3 groups. How big is each group if I'm taking nothing and splitting it up? It's going to be all the groups will have nothing in them. Nothing divided into 3 groups is still nothing. So 0 divided by 3 is 0. And even though I'm emphasizing this here, I'm going to see this mistake all the time. What's 3 divided by 0 conceptually? Yes. Is it? Let's think about what it means. 0 divided by 3 is 0, because I'm taking nothing and I'm dividing it into 3 groups. What does it mean to take 3 objects and divide them into no groups?
And then still remain together. So
No, that's a group. Remaining them together is a group. If I have you three are a fantastic example. I have 3 of you sitting here. As you sit, you are a group. You are one group of 3. I want to take all 3 of you. It would make sense if I divided you into 3 groups, right? If I took you 3, I divided you into 3 groups. Each group would have 1 of you. But what does it mean to take these 3 and divide them into no groups? Good. Do they? Because that's 1 group. We established that as they are, it's 1 group. Yeah.
Can I do it better? Example.
Yes.
Like now you have 2 pencils, right?
Yeah.
You're trying to like give it to, you don't have 2 pencils and you're trying to give it to other person. That's gonna be 0 because you don't have any pencils. But if I have 2 pencils and divide it, and if I give it 1 to him, 1 to him, that's group of 1. So if I have nothing and give it to them, it's nothing. I don't have a pencil.
Yeah, that's the first one we did. You have nothing. And
Yeah,
you
but
have,
then I have 3 now. I have 3 pencils.
Yeah.
Give it to each group 0. I keep all my 3 pencils. So that
no,
would,
that's still 1 group.
that would be 1.
That's the same problem, right? You still have 1 group of all the pencils that you didn't give away.
splitting 3 into 0 groups and just remain 3 groups.
No, because that's splitting them. That's allowing them to remain in 1 group.
Not gonna be 1.
No,
But
it's undefined. For the reason that we're having this argument, mathematicians just said, you know what? It does not make mathematical sense to divide a real number of things into nothing groups. It doesn't work. And so rather than continue to have this philosophical argument, they just said, okay, we're going to say that this particular mathematical operation is undefined. It means it does not have a definition. You cannot do it. If you are presented with this as an option, your answer is no. What is 3 divided by 0? No. Anything divided by 0? No. Can't do it, not defined. If you plug it into your calculator might tell you that it's undefined. It might use the notation UND. It might say error. It might say math error. Anytime a piece of technology gives you one of these 3, it means that you're asking it to do something that it was not programmed to do, because there is no programming for dividing by 0. 3 divided into no groups is anything divided by 0 is undefined. An important thing to remember. We're going to review long division. You have seen long division probably a couple different ways. How have you seen long division before? How were you taught it?
I'm not sure how to explain the symbol because I don't know what it's called, but it kind of just goes like,
Okay, so you're talking about this one, the curved one.
yeah, the curved one. That's
Okay.
What I've been doing this whole time. And then you put like the number that you're supposed to divide inside, and then you put the number that you're going to divide it by on the outside. So 2 would be on the outside and 24 on the inside.
You betcha. Pause that. Was anyone taught any different notation for this same procedure? Or were you all taught long division looks like this? Tired on a Wednesday morning. All of you were taught this symbol? Someone respond.
Yep.
Yes. Thank you, Mila. Okay, cool. It's not the only one that's out there. I had a student in the other class from the Dominican Republic. She said we were taught it this way. That's fine. So, but if none of you have seen it any other way, we'll do it this. How does long division work then here?
Okay, so basically what you want to do is you want to put the 2 underneath the first number that you have, which would be a 2. And then you want to know how many times it fits into that number.
Almost. You want to figure out how many times it fits before you put it under there.
Okay, you guys do that way. Okay.
Yes. No, that's you can't put it under there if it doesn't fit. So does 2 go into 2? Yeah, once. And now you multiply. 1 times 2 is 2. 0. Bring down the 4. How many times does 2 go into 4?
2 times.
Twice. 4, 0. And so what this means is
The answer is 12.
24 divided by 2 is 12. Yes, Kuntas. You betcha. It's frustrating when you get something like the next one I ask you to do long division, because is there a way to long divide 24 and 3?
Emulate, you could just use both numbers, or you could multiply 3 as many.
Let's do this. If I got 24 divided by 3, and if I want to do it the same way, before I said, okay, how many times does 2 go into the first digit? How many times does 3 go into 2?
0 times.
It doesn't. So now you're just saying, okay, how many times does 3 go into 24? That's just a math fact. You just need to, at some point, then memorize 3 goes into 24 how many times?
8 times.
8. There is no nice way to long divide that. Let's do one more.
Yay, which one are we doing?
91 over 7.
12.
Nope.
No? Did I do that?
Here we go. What is 91 divided by 7? How many times does 7 go into 9? Once. 1 times 7 is 7, 9 minus... And now you're subtracting. You're taking things away as you're making the groups. 9 minus 7 is 2. You bring down the 1. And now we want to figure out how many times does 7 go into 21? 3 times. So the answer is not 12. It is 13. Which is infinitely far away in math. Another way to take a look at it would be something... Actually, let's not do it that way. Let's not do that now. Long division. Okay. I'm going to leave this for you to do. These bottom 3. In a second, you're going to come back and take a look at those for homework. I want you to flip the page, and we're just going to we're going to have a conversation about a bunch of negatives, and then I'll let you get to work, because some of you are falling asleep, and I don't want to put you to sleep. So, multiplying or dividing rules. In general, when you are multiplying and dividing, the positives and the rules for positives and negatives are something you want to remember. We said a positive times a positive is positive. A positive times a negative is a negative. A negative times a positive is a negative. A negative times a negative is positive. This is the one I gave you the justification for with Pac-Man. So what about this? Question A. It doesn't say to determine what the product is. It just says, is it going to be positive or negative when I multiply these 3 things together? Someone other than Pavneet. She has said lots of things today. Yes. Why? You're correct. Why? You betcha. We said before, and I think we reasonably were able to justify why that a negative times a negative is a positive. So when I've got 3 negatives here, the first 2 are going to multiply together, give you something positive because of this rule. And now if I've got 1 more negative to multiply on here, it's going to be a positive now times a negative. It's going to give me a value that is negative. So if you have an odd number of negatives, I have 3 negatives multiplied together here, the result is always going to be negative. And so that means if I've got an even number, like in little question B here, those 2 negatives are going to give me something. These 2 negatives are going to give me something. And those 2 positives are going to give me a positive value. Dealing with the negatives first can make your life a lot easier, especially when you've got a bunch of things to multiply, something like this here. I'll do the last one for you. I'm not going to multiply it out with the negatives, but first I'm going to determine whether or not the thing is going to be positive or negative. What's it going to be? It's going to be negative. I've got 1, 2, 3, 4, 5 negatives. Your final answer is negative. Well, and now what is it? Now we don't need to worry about the negatives. What's 5 times 2?
10.
10. 10 times 1 is? 10 times 1 is? 10 times 2 is? 20. So your final answer then is going to be negative 20. We tossed the negative outside. We dealt with it. And then we went ahead and did the math, the mental math. Okay. Half hour left. I'm going to release you to try a bunch of things. I want you to do these 3 questions. I want you to show me your technique for long division. This might be the only time I ask you to do that, but I want to see it here. I want you to finish this page. This one just says don't calculate. Tell me if it's positive or negative. This one actually wants you to do all of them. Then I want you to flip the page and I want you to crank these bad boys out. There's 38 questions there. They are all multiplication or division. If you've got any questions while you're looking at those, let me know. Otherwise, may the force be with y'all. Get to work.